Okay, so can we all see the exponential or the radical? The radical in this case is this x minus 2, which is being raised to the 2/3. So what do I have to do to isolate it? Divide by 2, right? Both sides divide by 2. So now we've got x minus 2 to the 2/3 equals 25. Okay, now remember what I wrote on the last step. To undo raising it to a fraction as an exponent, raise both sides to the reciprocal fraction power. I mean, what's the reciprocal of 2/3? 3/2. So raise it to the 3/2. 3/2. Okay, because again, remember, when you raise a power to a power, how do you simplify? You multiply, and what's 2/3 times 3/2? 1, right? When you multiply reciprocals, you always get 1. So that's a way to make it just the x minus 2, right? It's x minus 2 to the first, but we don't have to write that to the first power. How about the right-hand side? Okay, remember, you could put this in the calculator, just go 25 hat 3/2. But you should be able to think of it like this, right? What's the square root of 25? 5. What's 5 to the 3rd? 125. Okay. However, there is a detail in here, which is what makes these problems a little bit more difficult than what we just saw. It's more difficult when you're doing with rational exponents instead. When we did this raised to the 3/2 power, right? What kind of a radical is it that has a denominator of 2? It's a square root, right? And what do we know about the sign of square roots? Or any even root? They got to be positive, right? But we got x minus 2 here, and x is a variable, and it's possible based on the value of x that this could be negative. But it can't be, because when you take an even root, it has to be a positive number. And this is why in that first section of the chapter, they had that part where we would have to use absolute value symbols. This is where it comes in. Because we took a square root, this has to be positive, so we have to put that in absolute value symbols. Okay, because this denominator is even. Whenever that's even, you need the absolute value symbols. Okay, let me change that to red. Okay, well, that means we got to remember, how do we solve absolute values? And they had their own procedures. The first of which was isolate, but it is isolated. How did we break it down so that there were no more absolute value symbols? Incorrect. The x minus 2 equals 125, that's one of them. What's the other one? X minus 2 equals negative 125. Right? Because if that's true, right, if that's negative 125, when you take the absolute value, then it's positive 125. But you don't want to just like say x plus 2. That's not correct. Okay, so solve both of those. X equals, add 2, 127. Add 2, x equals negative 123. Right, so when we got to this solve what's left, we had to do an absolute value. First was a linear, now it's an absolute value. And again, it was only because this power, when we raised it to this power, had an even denominator.